Alright, let's look at the practice exam 1, problem number 9. Alright, we want to evaluate this improper integral. Alright, so this is improper because the interval of integration is infinitely long. Alright, so first thing I would do is I'm going to use a substitution to make it look a little bit simpler. Alright, so here's the substitution. I'm going to let u be the denominator, so x squared plus 5. Right? Then we take the derivative of u with respect to x. Right? We'll get the derivative of x squared is 2x, and derivative of 5 is 0 since 5 is a constant. Right, then I'm gonna take the reciprocal of both sides, so I indicate it by raise it to the -1. So basically we just put it upside down, so dx on top over du, and the reciprocal of 2x is 1 over 2x. Alright, then we multiply both sides by du so that we can isolate dx. So dx is equal to du over 2x. Alright, then next thing I would need to do is we need to convert the lower limit and the upper limit of integration. So originally x goes from 0 to negative infinity. Right, 0 to negative infinity. Right. Then we need to convert it to corresponding u value. So we plug 0 into this substitution equation. 0 squared plus 5 is 5, so y starts from 5. Right? Then plug in negative infinity. Negative infinity squared plus 5 is going to be positive infinity, so it goes to positive infinity. Alright? So let's rewrite that using this substitution. So this is going to be integral from 5 to infinity. Alright, remember that we decided to call the denominator here. So this is the guy we decided to call u. Alright, so we have x, I'm going to leave it as it is. I'm going to take care of this guy later. Alright, so denominator is u. Alright, then we have dx. dx, we just found that the same thing as du over 2x. So I'm going to put du here over 2x. Alright, then luckily we can cancel x on top, so cancel that, and the x on the bottom. Right, and also since there's 2 on the bottom, right, and it's just a constant, I'll just kick this guy out of the integral and put it in front. Right, so that's going to be, right, so this is equal to, right, so it's a 2 on the bottom, so it's a 1/2 is a constant in front. Right, next thing we need to take care of would be this guy. So this is the reason why this is improper. So you have infinity for the upper limit. So I'm going to replace that guy by say b. So it's instead of going from 5 to infinity, and I'm going to stop at some number b. Right? Then let's see, we have to clean this up. So you have a 1 over u. Alright, and the du is what's left because 2 is taken care of and x's are canceled out. Alright, then we take the limit as b approaches positive infinity. Alright, then we can find the antiderivative of this. So this is equal to 1/2 limit b approaches positive infinity. Alright, so this guy is going to be an antiderivative of 1 over u is natural log of absolute value of u. Right, then this goes from 5 to b. Alright, so let's just plug in. So you have 1/2 limit as b approaches infinity, and we plug in b, so you have a natural log of b. I guess absolute value b, it's not going to really matter because b going to positive infinity, minus natural log of absolute value of 5. Again, absolute value sign doesn't really do anything because 5 is already positive. Alright, so we have that. Alright, but as b approaches infinity, natural log is going to go to infinity. So we know that natural log of b approaches positive infinity. Subtracting some small number, natural log of 5, it really doesn't change anything. And divide by 2 is still going to infinity. So this limit actually goes to infinity, right? Which means that here this improper integral diverges. So here this is going to be, maybe I should say, divergent. Alright, so this would be the answer for problem number 9, part A. Alright, that's it. I hope that this was clear.